we're going to be simplifying this rational expression. And essentially, you're going to be taking this negative third exponent and distributing it to all parts inside the parenthesis. However, before I start that, I do notice that I can make my numbers at least a lot smaller here, because I could take 10 and divide that by 5, which gives me an answer of 2. So I'm going to erase this 10 and write a 2 there instead. This is just 2 because 10 divided by 5 was 2. If you want to put a 1 in the denominator, you can. 2 over 1 is the same thing as 2. All right, so now I'm going to take 2 and raise that to the negative third power. That's the beginning part here. So 2 to the negative third. Remember, a negative exponent, to simplify, ignore the negative, figure out what the positive exponent value would be. So that would give me an answer of 8. 2 to the third is 8. And then I take that answer, which is just 8 over 1, and find the reciprocal of that. So if I find the reciprocal, which is what the negative exponent actually means, it would be 1 over 8. So to start recording my answer, I know I have 1 over 8. So again, I need to distribute this to all of the parts inside the parentheses. So now I'm on to x to the third to the negative third. And again, I'm applying the rule that says if you have an exponent raised to an exponent, you multiply the exponents. So this would be x to the 3 times negative 3 is negative 9. Now I'm taking y squared and raising it to the negative third. Multiply my exponents. 2 times negative 3 is negative 6. All right, now I need to take x to the negative third and raise it to the negative third. Multiply my exponents. Negative 3 times negative 3 is positive 9. And lastly, y to the fourth raised to the negative third. Multiply my exponents. 4 times negative 3 is negative 12. So from here, there's 2 routes you can take. You can either use this division rule and take a look at your base x and then your base y and apply that rule, subtract the exponents. Or you can look for all negative exponents and switch their position. For instance, I see a negative exponent here. So I know negative exponents mean the reciprocal of the positive value, so that means this would go in the denominator. This exponent also would go in the denominator, and then this negative exponent would switch to the numerator. So when I rewrite my fraction right now, I still have 1/8 x to the 9th stayed in the denominator. But now let's start with this first circled expression, x to the negative 9th. That's going to switch to the denominator, so it's going to be x to the 9th in the denominator. So I'm done with that one, kind of shaded out. Now let's look at y to the negative 6. When that goes in the denominator's position, it's going to be y to the positive 6th. So that one is done. And lastly, now I'm on to the y to the negative 12th, which is moving up to the numerator. So when it goes to the numerator's position, it will be y to the positive 12th. Okay, so those are done. All right, so to continue simplifying, first thing I notice is the numerator is just y to the 12th. The denominator is 8 times, well, I have base x here to the 9th times base x to the 9th. So I could use my rule here that says if they have the same base and you are multiplying, you add the exponents. So 9 plus 9 would be 18. So in my denominator, I have x to the 18th and then y to the 6th. So finally, taking this and simplifying that, so y to the 12th over 8x to the 18th, y to the 6th. I do have to combine my base y here using this rule that says if they have the same base and you're dividing, you're subtracting the exponents. So this is really y to the 12 minus 6, which is y to the 6. Because that's positive, it's going to stay in the numerator's position. So my final answer, I have y to the 6 in the numerator, 8x to the 18th in the denominator.